Okay, we're in section 5, the notes. This is calculating limits. And certainly, hopefully, you've paid attention during the prior lectures and examples and done the homework and realized the way we're doing limits is going to require some more thinking. And some of the thinking is going to have to do with laws. All right. My suggestion over here is it's a very short lecture. Kind of listen through this, but the bottom line, I also want to recommend that you read your textbook about the limit laws. All right. About when I say textbook, any textbook that you have is fine, right? Almost all calculus textbooks out there are going to be excellent books to read through. All right. So we'll talk about. I'll go to the whiteboard, and I'm not going to read them verbatim to you, but I'll go to the whiteboard. It'll be short though. So after we go through this, we'll talk about this. We'll talk about some of the issues with it. We'll start doing examples, and we use the limit laws. Now, when I do the examples, it's going to look different than they do in a textbook. In a textbook, they're constantly writing down what laws they're using, and then these problems, which I think are very simple, I talk through them. In a textbook, what they do is they write down each limit law and each step they're going to take. Right? I tend to skip a lot of steps and kind of just talk through the limit laws as I'm doing the problems. Right. So what we're going to do is go to the whiteboard and we'll discuss the limit laws. Just give me 1 second to do so. And I got to get this working here. All right, you see my white screen. And on the white screen, what are you seeing? You're seeing that section that says limit laws. And we're going to read through it. And I'll use my highlighter. So this one over here says, suppose C is a constant. All right, so what does that mean? C is some real number. And then we have these two limits. These two limits exist. All right, let me outline that for you, what they're saying over here. They're saying this limit here and this limit here exist. So what I'm going to claim over here, if they're telling me that, what they're basically telling me is that these things actually have limits. So I'm going to say this is the limit of the second one. This is the limit of the first one. Now, what does that mean? L1 and L2 are some finite number. All right. Now, what do they go on to say? If this is true, and again, if C is a constant, and they're saying the limit of this first function, f of x, when you go towards a, and the limit of the second function of g of x when you go towards a, are both finite. All right. So what do you got over here? You got this over here. I'll write this down for you. They're going to say the sum of these two guys, when you take the limit of it, is just a sum of their individual limits. All right. So what I got over here is you're adding these two guys together. You can start to, separate into two separate problems. All right. Difference. You can separate into two separate problems. All right, let's keep going. If you got a constant multiple, what you can do is take a constant multiple of the limit now. All right. So again, it's fairly, if you know the limits of f and g as x approaches a, there's some difference in constant multiple. Products, not much of a stretch here. I can look at it as a product of two separate limits now. All right. Quotients, a little hard to understand. What do they do? Say limit of quotient. Well, I can take the limit of the top, limit of the bottom, but then they got this if things. Provide the limit of the bottom is not zero. If the limit is not zero, this wouldn't apply. All right, let's keep going. These are the basic laws. If you look at a book, you're going to see a lot more though. Bottom line, you need to carefully think about getting close to a number without actually touching it. This is going to be our main goal here, getting close to a number, but not touching it. The other problem we have is we're going to approach numbers from two different sides, and this is often confused. People often think that limit laws allow them to blindly plug in without thinking about approaching things from two different sides. In some cases, it does allow us to blindly plug in, right? However, I want to again get a stress to you. You really need to start thinking about getting close, not touching it, but also approaching things from two sides. You must think carefully about that. All right. So anyway, let's go to some more limit laws. What are we doing over here? Well, we're going to take that function now raised to a power. What are they saying? you can look at the limit of the function f and then raise it to the power, provided the n is a positive integer. Now, what does that mean? Well, let me write down what the set of n would be. If n's a positive integer, like 1, maybe I should write that down. So like, 1, 2, 3, yada, yada, yada. All right. So the next one, which is really going to be something that's really going to be important. This one over here, we use this a lot. And that certainly makes sense to me. If x is approaching a of a constant's never going to change. It's always going to be c. This one over here, kind of introduction to polynomials. Basically, it's a substitution rule. All right. If x is a polynomial, just substitute it in. All right. It is x is a polynomial. I should say if f is a polynomial, just plug it in. All right. We're seeing that right over here. Again, n is a positive integer. Basically, just a plug-in. That's all we're doing. Here's where we get something else a little bit strange, by the way. They talk about nth roots. That is not a polynomial. They say the nth root of a. That's not bad. It's like a plug-in. N is an integer, positive integer. Here's what they say, though, which is hard to understand. If n is even, we must have a greater than 0. And let me go through that, why that is. Let's take a look at a simple example. I'm going to look at this example over here. Whoops. I'm going to look at this example over here. Limit as x approaches a. Let's use the simplest even root. N is an even number. Let's do the square root. You should have some idea over here that we're looking at a square root function. That's a square root function. F of x equals the root of x. But what they're saying over here is that you're going to have a problem at this. And why is that? You can't approach it from the left. You can't approach it from the left. That's so important. That's why they're saying the a has to be greater than 0. That's why they're saying that. Bring us back over here. This is something that's going to require some thought on your end. My gut feeling over here is if you draw a picture, it's going to be kind of easy if you draw a picture of it. You'll realize you can't approach it from both sides of 0 for even roots, right? Is that true for odd roots? No. Odd roots have a domain of ordinal numbers. All right, let's look at the last one. And again, this will get us through the problem set. Again, this requires a little bit of thinking. And what are they saying over here? Well, the limit as x approaches a of the nth root of f of x. Well, we can go to the inside, but again, they got this thing over here. The n's got to be a positive integer. And they say if n is even, again, it's that even thing over here, the f of x must be, the limit of x approaches a of f of x must be greater than 0. And again, why is that? Well, if we thought about it, we need to be approaching from the right of 0. And why is that? It's the nth root. And if the nth root is even, it's got to be a positive number because we can't approach it through negatives. All right. So I'm going to claim that this can be quite confusing to students. And basically, a lot of students, they boil down as to this. They say, oh, when I say a limit, I'm just going to plug the number in and hope for the best. Generally, that works. Here's the problem. It doesn't always work. So what we're going to do is go through examples to indicate this problem that we have with the limit laws. Yes, we're going to be using limit laws, but we're going to be looking at the issues with the limit laws. All right. So I'm going to say that for the most part, they're kind of easily understood. It looks almost like we're substituting in with some exceptions. All right. With some exceptions. And we'll go through those. I can't say this enough times, though. When I say plugging in, we're kind of using laws to allow us to touch something. But limits are saying don't touch it. They're saying get close to it. You should still think about limits, about getting close, but not touching, right? Getting close, but not touching. You should also think about limits as approaching a number from both the left and the right. Let me add on what I'm saying over here. So what's happening to the function as x goes close to a, but don't touch a? Left and right are still going to be incredibly important, and you should think about that at all times. All right. Okay. Sometimes you're going to be given left, something going to be right. Oftentimes you're just given, as we approach the A, we make sure you understand left and right needs to be thought about. Right. On occasions, you're going to be horribly confused. I'm going to say as a last resort, you can resort to tables and graphs as we've done in the past. All right. All right. That ends the lecture part. Again, I'm going to emphasize here read your book. What section? Limit laws. Think about it. All right, it requires thought. Next up, examples. After we do examples, you need to start the try. I'm going to say the try is from study of what's being presented and then doing as many examples as you possibly can. Thank you.